In this video, I'm going to be talking about how to find the lateral area and the total surface area of a triangular prism. There's a little bit more involved here because they're not all rectangles, which is just base times height. We need to find the area of rectangles and triangles for this one. So I've got a little bit of a model right here. I have to zoom out a little bit. There we go. So here's my triangular prism that I've made right there. And you can see that on either end there is a triangle, and the one I've made is pretty close to an equilateral triangle. And on the outside, on the sides here, I've really got three rectangles. Kind of see them there. 1, 2, 3, three rectangles. So the lateral area is three rectangles. When we put those three rectangles together like this, you end up with two triangles on either side. So there's 5 faces total on the triangular prism. 3 of them are rectangles and 2 of them are triangles. Rectangles are a lot easier to find the area of. To find the area of a rectangle, you just need to find the base times the height. And on this triangular prism in the picture here, the base is going to be 3. So it says so right here, 3 inches. So this is 3. And the length here is 6. So the base and the height of this side rectangle, or even the bottom rectangle, I guess I should say. So the bottom rectangle here matches with the bottom rectangle right here on the bottom, is going to be 3 by 6, which is 18. So the bottom rectangle is 18. It just so happens that this is an equilateral triangle, which means that all the rectangles are going to have the same dimensions. The side one on the right side here is going to be 3 by 6 again. That's another 18. And the one on the left side is also going to be 3 by 6. So this one right here, see if I can do it, there we go, is 6 by 3. That's 18 square inches for that rectangle. This one is 6 by 3. Gives us 18 square inches, and the bottom is 6 by 3, another 18 square inches. 18 plus 18 plus 18 is going to be 54 square inches. Sorry, square feet. Wait, that's actually wrong. This symbol here, the 2 little dashes, that means inches. And then they put feet down here. Somebody screwed up at Odyssey. It should be 54 though, regardless of the unit. All right, now let's talk about the more difficult thing. Total area. Okay. I'm going to, while I'm talking here, I'm drawing. I know you can't see what I'm drawing. Move over to this. Okay. If we want to find the total area, the total surface area, we need to add up the 3 rectangles around the outside, and then add that to the 2 triangles on either end to get the total area. So the lateral area we already know is, I'm going to stick with inches here, but there we go. The lateral area is 54. There we go. And we need to find the area of the triangle. So I'm going to redraw the triangle over here just so we can look at it head on. In an earlier lesson, I'm not going to pull it up right now because I'd have to leave this problem. But in an earlier lesson, I think it was areas of polygons, I believe, you had to do a whole bunch of problems where they asked you the area of an equilateral triangle. I'm not going to go back into that whole lesson. I'm not going to teach it in depth. But one pattern that hopefully you saw or you found, because you passed that lesson, is that the height of an equilateral triangle, which we need to find the area of a triangle, I'll remind you, we do the base times the height divided by 2. So that's the area of a triangle, of any triangle. We know the base. The base is 3. It always happens to work out on an equilateral triangle that if you draw that height in, from here to here is half of whatever this side is, 1.5. And because this ends up being a 30, 60, 90 triangle, the height always ends up being whatever this is, so half of 3 in this case, 1.5 times the square root of 3. Can't really see that too well because I'm writing so small. But the height ends up being 1.5 times the square root of 3. And The square root of 3 is always the square root of 3. Even if this was a 4, a 5, a 6, a 7, it wouldn't matter. This would always be the square root of 3. And that's just the way it works out. It's a pattern that we find if you do the Pythagorean theorem. And that showed up in an earlier lesson. Okay, so now we know the base. The base is 3. We know the height. The height is 1.5 root 3 divided by 2. That's the area. 3 times 1.5, we can do that. Times square root of 3, leave that as square root of 3. Don't make that into a decimal. You'll notice here in the answer, they have the square root as part of it. So they don't want you to change that into a decimal. If you do 3 times 1.5, you're going to get 4.5. And 4.5 divided by 2 is going to be 2.25. I left that square root of 3 alone because it's a crazy irrational decimal. It's not pretty. It never repeats. It never ends. And that, let's see if I can get rid of this stuff down here. All right. If you look down here at the answer, there's that square root of 3 area, but they've got a fraction here. They don't have a decimal. So we need to change this to a fraction. 0.25, that's the same as 1/4. 25 cents or 1/4. So that's 2 1/4, square root of 3. And if I want to change this to an improper fraction without getting really deep into how this works, I'm just going to use the shortcut. If I do 4 times 2 plus 1, the denominator times the whole number plus the numerator, I'm going to get 9/4 root 3. And that's the area of the triangle. The total area is the is the area of all 3 rectangles, 54 inches, square inches, plus the 2 triangles. Now, one thing I forgot about is that I only found the area of 1 triangle. 2.25, that's the area of 1 triangle. But we have 2 triangles. So I'm gonna draw a line here. This isn't wrong what I've done down here, but that's just for 1 triangle. There are 2 triangles on this shape. So I'm going to go ahead, I'm going to multiply this times 2. $2.25 times 2 would be $4.50. $2 and $2 is $4, 25 cents, 25 cents, that's 50 cents. So 2.25 times 2, 4.5. That square root of 3 is still the square root of 3. There's not much I can do with that right now because these are not like terms, so I can't multiply them together. 3 times 2, because this has a square root and this doesn't. So I can't really mess with those very much. Square root of 3 is just there. Okay, changing that to a fraction, because this is both of my triangles now. 4.5 is 4.5. Again, I'm going to use the same shortcut. 2 times 4 is 8, plus 1, 9/2. Root 3, not 9/4. So this was for 1 triangle. This is for 2 triangles, because that's how many I have. So I need to use this number here, because there are 2 triangles on this shape. Okay, almost done. These are a lot more work than the rectangles. We have the lateral area is 54. And I need to add the 2 triangles. 2 triangles would be 9/2 root 3. That does not look like a very elegant solution. You know, there's this plus in there and a square root of 3, but this is the most precise answer you could give without rounding a decimal. And that's what's going to end up going right here. Triangular prisms, a lot more work. There's 2 other triangular prism questions, I think, number 7 and number 8. One asks for the lateral area, one asks for the total area. If you're stuck on those, let me know, and I will walk you through those as well.